Okay, this is my favorite lesson actually when it comes to trig functions. This is the one where we start looking at graphs and trying to find the equations, or taking equations and try and graph them. And I always like this just because you get to work from the graph and come up with the actual formula. And I don't think it's actually that hard. There's basically three easy letters to solve for, but you have to remember how to find all three of them, and then one of them is a little bit harder. The hard one, I would say, is the C value. They call it C on here. I don't know why. What do we call it? H. So that should be H. That should be K. I think the H is a little bit harder to solve for, but the rest aren't too bad. Okay, what's the easiest one to solve for? I would guess you might say K. Where's the middle of the graph? Wherever the middle is the K value. So K is equal to 30. No way around that. Trig functions are always anchored by whatever that vertical shift is, up and down. They're always equally on both halves of it. There's no other way to graph them. So wherever the middle is the K value. If you really can't solve it, you have to take the max, subtract the min, and divide it by 2 to find that. Is that right? Oh, and then add that to the minimum number, and that will find you your thing. And that's working from the amplitude. So we have to do that next anyway. I think the next easiest thing to find is A, the amplitude. You can think of it one of two ways. How far from the mid have you traveled? Or you can use the formula max subtract min divided by 2. Halfway of the entire range. Either way, you should get 15. If you want to see it as a formula, you do max 45, subtract the min, which is 15. That gives you your range, and then cut it in half. And that should be your amplitude. Okay, the next one, B value. So the period is equal to 2 pi divided by whatever your B value is our formula. This is maybe one of the harder memorization ones. The rest of that's fairly intuitive. This one you really have to memorize. Which means, what is our actual period here? How long does it take to repeat itself? This is not the period, going from 0 to 16. It hasn't gone through the whole cycle yet. Here is. It should be till 32. So 32 is equal to 2 pi over b. So b is equal to 2 pi over 32, or b is equal to, just switch spots. And then I'm going to divide the coefficients. 2 over 32 is 1 over 16. Just canceling out the 2 and the 32 like it's a fraction. Becomes 1 over 16. So our b value that we're going to put in there is going to be pi over 16. Okay, now the one that's a little bit harder to find, our h value. It's actually not too bad once you know what to look for. This is the only one that you can't just like punch in though. There's a couple things you have to note. Are you doing it with the sine function, or are you doing it with the cos function? Either one can work because they're the same curve, they just start at different places. So you could actually represent this with either curve, and all three of these values would be the same. Only the h value would be different depending on which one you're picking. By default, we almost always pick sine to be our curve. I don't know why, we just like sine more. Now the question is, where is the beginning of your sine curve, and how far has it moved? So to be the beginning of your sine curve, you must be on the axis of symmetry, and you must be about to go up. And that would be this point right here. That's on my axis of symmetry, about to go up. Which means we have shifted 16 units to the right. Now a couple notes. You might think, hey, we could be going down first, in which case this would be the beginning of my function, but I would have to turn my a value into negative. And that's true, that's another way to write it, but we generally just like to keep the a values positive and then look for the first point where you're about to go up. So if you do it this way, your a value will always be positive. You never have to worry about a flipped upside down graph, because you could just shift it. You could account for that with your new h value. Same thing with, actually that's about it. Yeah, if you were going to do it with coast, there's different ways as well. But no, look for the point on the axis of symmetry about to go up. And then we rewrite all this into the formula. So this would be h of t is equal to 15 times sine of pi over 16. Make sure your b value is a common factor. And then we have our t minus 16. Don't forget the minus in there as well. And then we have plus 30 at the end. And that's our formula. Again, I think that's pretty fun to come up with, and it's not too hard. We're going to try a couple more. A nail is caught in the tread of a rotating tire at point N in the following sketch. Okay, so the tire spins, and the line represents the height of the nail as it spins. The tire has a diameter of 50 centimeters and rotates at 10 revolutions per minute. After 4.5 seconds, the nail touches the ground. Use the information to write a scale for each axis. Okay, a tire has a diameter of 50 centimeters. We don't know that the nail is on the outside of the tire. It says it's in the tread. Let's assume it's right on the outside, in which case the top is going to be 50. Not the radius, the diameter. That dash is a little bit low. Should be up here. Okay, so the top is 50 centimeters, 10 revolutions per minute, which means 1 revolution is in 1/10 of a minute. And where is 1 revolution? Well, right around here. So if we have t is time in minutes, then this is 1/10 of a minute. And over here would be 2/10. Oh, it actually says time in seconds. So we would have to times this by 60 then. So that's actually 60 over 10, which is 6 per minute. And then that's 12. 12 seconds. So 6 seconds and 12 seconds. It should be done an entire rotation. Those are nicer numbers. Seconds much better. And then after 4.5 seconds, the nail touches the ground. That's our 4.5. Okay, so we've got our axes labeled. This is 0, and this is 0. Determine the equation for the height of the nail as a function of time in the form blah, blah, blah. This one wants no h value because it actually starts right at the beginning. So there is actually no h value this time. So we just have to find each. What's our amplitude? Well, it goes from 0 to 50, but it's half that, so it's 25. What is our k value? I'm going to call it k, even if they call it d here. So our k value is the middle. That should be 25 as well. That's because they're the same number. That means the bottom of the tire is going to be at 0. And then we need our b value, which is equal to 2 pi divided by the period, which is equal to, yes, I know that's the different formula. You can quickly just flip those spots, and it works out just fine. So 2 pi divided by 6 is pi over 3. Good. So h of t is 25 sine of pi over 3 t plus 25. And you probably should sketch this in your graphing calculator and make sure it looks okay. But I think that should be the correct answer. How far to the nearest 1/10 of a centimeter is the nail above the ground after 6.5 seconds? So all you have to do, sub nt equals 6.5 and solve. You can do that really quickly with the calculator, with the graphing part of the calculator, or with the number part. Either way should work just fine. Because this is 6.5 should be, it should be just over 25. I'm going to guess it's around 30. And I've got the answer right here. You should get the answer. 37.5 centimeters. All you have to do is sub it into the equation. Okay. 2 more questions. Yeah. But this time we have to do the graphing ourselves. The first Ferris wheel ever built was created by a bridge builder by the name of George W. Ferris in 1893. The diameter of the wheel was approximately 76 meters, and the maximum height of the wheel was 80 meters. Interesting. So it went 80 meters in the air, but it's only 76 meters around, so it does not hit the ground. It's a little bit off the ground. It has 36 carts on the wheel, with each cart able to hold 60 people. If the wheel rotates every 3 minutes, draw a graph which represents the height of a cart in meters as a function of time in minutes. Assume that the cart is at its highest position, t equals 0. So we're going to start at the top. So at 0, we have a max height of 80. In meters, I'm assuming. So we're going to be starting, let me get another pen. Oh, I got a great one here. Oh, if it works. We're starting at the max height at time 0. Okay, so we know the vertical scale. We know it's going to go down 76 meters, so it's going to be 4 meters off the ground when it hits the bottom. We do one circle. Where does it actually say that? It rotates, if the wheel rotates every 3 minutes. So after 3 minutes, maybe we'll do 2 rotations on here. After 3 minutes, it's back up to the top. And after 6 minutes, it's back up to the top again. So when should it be at the bottom? Well, exactly halfway between them. So 1.5 minutes. Let's try and fill in the blanks here. At 1.5 minutes, it should be at the bottom. And at 4.5 minutes, it should be at the bottom. Now, when's it at the axis of symmetry? Well, halfway between those. What's half of... where's my calculator? What's half of 1.5 minutes? Well, that's 60, 90. Half of 90 is 45 seconds. So 3/4. And 1/4 of the way past that line. 3/4 of the way past that line. And 1/4 of the way past that line. So that's pretty much all the points we need. And then we need to connect it together into a nice little sinusoidal graph. The hard part is getting it flat at the top. Something like that. Did we match everything we needed? Draw a graph which represents the height as a function of time in minutes. Yeah. Show 3 complete cycles. We'll say 2. Okay. Actually, I don't even think you said, yours didn't even say to do 2 complete cycles. Oh, you have a different question. Oh no. You're given a table of values. Interesting. At time 0, it's got a height of 4. So, okay, sorry, ignore this. But you should be doing a similar thing anyway. Just you're starting at the bottom. So you're starting at a height of 4. You're going up to 80. So basically, yours looks like this. That right there. Should look like yours with different times. And it actually says yours takes 9 minutes to do one complete cycle. Interesting. Okay, we'll use your values from now on though. Hopefully you can graph that just fine. Determine the equation of the graph in the form. Ooh, this time they want it with a cos. Interesting. Okay, so what do we know about this function? We're going to use yours. So I'm going to call this the beginning. And call this the end. And that's time 0, and that's time 9. So this is time 4.5. Okay, first of all, amplitude. Well, we know the diameter is 76, so the amplitude should be half that. Should be 38 up and 38 down to make a total of 76. So that one's easy. What else is easy? Our k value. Well, that should be 40. I think that's the same for you guys as well. Oh wait, it's not 40. Ha ha ha. That's one tricky thing about this. So you do have to be careful with the k value. The k value is exactly in the middle, but it doesn't go to 0. I drew my graph poorly. So hopefully you drew it better. I just forgot that. It should stop at 4. It should be up here and up here. Don't know how I missed that actually. So it is exactly 38 higher than 4 or 38 less than 80. So it's actually 42 should be our k value. The middle should be 42. They leave a little gap off the ground so that you can actually load the carts, which makes sense. And so it doesn't hit the ground as it spins. What's the next one we need? We need the b value. So b is equal to 2 pi over the period. And our period in this one is 9, so 2 pi over 9. And we probably just leave it just like that. And then we also need our h value. It doesn't say an h value. Oh, that's why. So if we're using the cos function, if this was the sine function, we would need the beginning to be right here, because that's on the axis about to go up, and we would need to find what that point is, which is halfway between 0 and 4.5. And that's how we would find the h value. But since we're doing the cos function, remember cos actually starts, where does it begin? Do you guys remember? Sometimes I have to look it up really quick. I'm pretty sure it starts at the top though. Yes, it starts at the top. Cos function starts at 1 and goes down. So we're looking for the point on this graph where it starts at the beginning and is about to go down. So it could be the very, very top. Now it tells you not to use an h value. We could make the h value 4.5. And that would work just fine. Or we could do something else instead. If we had to put it in this form like it's asking for, and you might get something like this on the diploma. If you're not allowed to use an h value, and we're not starting at the right place, what could I do instead? We could call a negative 38. We could say this is the cos function that's been flipped vertically. Now I say we don't usually do that, but you can do that just fine. So this time it actually starts at the start just flipped vertically, in which case the h value is 0 and we don't have to worry about it. So in this time it would be h of t is equal to negative 38 cos of 2 pi over 9 t plus 42. Fun. Or if you didn't put the negative there, you have to have another set of brackets and you have to do subtract 4.5 inside. Either way works just fine. How high is the car at 5 minutes after it starts? Is that your question? How high to the nearest meter is the car at 5 minutes? Yeah, you have that question. So this is just solving. H of t is equal to negative 38 cos of 2 pi over 9 of 5 plus 42. And if you're in radian mode, you should be able to get an answer pretty quick from that, which is 78 meters. Makes sense. 5 is very close to the top, so it should be very close to the top. How many seconds after the wheel starts rotating does the cart first reach 10 meters from the ground? Interesting. So we could do this by graphing. I would solve this one by graphing. So how far after it starts rotating does it reach 10 meters from the ground? So we would make a line y equals 10, and we would find the first point of intersection. And if you do that, you should get x equals 0.8159. So you got to times that by 60, and it should be 49 seconds. And we do a little sentence. So therefore, first time at 10 meters is 49 seconds after it begins, after it starts. Good. Something like that. So these word problems, there's always kind of two types. There's the x equals a number, in which case I call these the plug and plays. Just put them into the equation, or you can use your calculator and solve. And then I get the y equals numbers, and these are the rearranged ones. And with trig, these are a fair bit harder than normal equations. And sometimes there's multiple solutions. So I would always try and solve these with the graphing calculator part, if it doesn't tell you otherwise. Okay, that was it for you guys. You don't have this last question. Oh, maybe this was your question. No, that's a different question entirely anyway. Okay, so that's how to get equations from graphs, or how to graph them and get the equation from that. I think this isn't too bad actually. So it's kind of an easy end to the lessons. Good luck on the homework.